Okay. Good afternoon, everyone. Good morning pala, everyone. Today, i-continue ko lang yung last lecture 2 and then pre-record again yung lecture 3, which is the plate tectonics. Okay. So, we were discussing yung Earth's large-scale features and then followed by the isostasy, the concept of isostasy. Okay. So, when we look at this map, there are several features which we notice. Of course, there are the continents, such as this yellow parts, as well as the oceans, itong nasa blue. Yung continents natin and yung oceans, we can immediately see mountains lining up yung ibang regions. For example, here, you have this continuous uh, chain of mountains or belts of mountains dito rin sa uh, America. Dito sa North America, you have this chain along the west coast. Sa South America, along the west coast din of South America, you also see these mountains. And in some regions, you can clearly see na those areas of mountains are actually just after or immediately close to a very dark region sa oceans natin, which we refer to actually as trenches. So we'll get more into that kung bakit may trenches and bakit may kasama silang mountains like this in the continents. Sa oceans then we can see two sets of mountains. The first one the first one are the spreading ridges which we've discussed before. So we can see these continuous mountains, for example, in the Atlantic, here in the Pacific, and also there are individual chains of mountains like this ones. This is actually the Hawaiian group of islands. This is the Hawaiian group of islands and then the Emperor Seamount chain. So yun na yung keyword ninyo, seamounts. We'll discuss later kung paano sila na-form. But just in a nutshell, they represent actually volcanoes as well, submarine volcanoes as well. Yeah. So again, dito sa region, we can see, ito yung Pacific Ocean, of course, and then ito yung Philippine Sea, which we refer to this region as the Philippine Sea. So we can also see dark regions here lining yung boundary ng Philippine Sea. So those are actually the trenches. This is the deepest point on Earth, the Marianas Trench, and then the second deepest point in Earth, which is Earth's crust, which is the uh, Philippine Trench. So trenches line this Philippine Sea, and to the east of that Philippine Sea is the Pacific Ocean. Yeah. So mountain belts, mountain ranges, trenches, um, spreading ridges, oceans, as well as individual mountain or volcanic chains like this one. Yeah. And then we also of course have flatlands like this. So areas na relatively parang walang nangyari, wala masyadong mountains, kunwari sa Africa, for much of Europe, Europe and Asia, medyo flat yung area. So bakit kaya siya ganun? And of course, Australia. So we'll discuss that in more detail in the next lecture. But let's discuss yung features na to. So we have mountains, which are again elevated features of continents, and this chain of mountains can form ranges or chains of mountains. So we refer to that as mountain ranges. Mountain belts are also mountain ranges across a vast area. Usually, mountains, mountain ranges, and mountain belts. This hindi yan siya popping out of nowhere lang. As we'll learn later on, there are processes which bring about the formation of mountains. For example, we'll get to discuss orogenic belts and volcanic arcs. Orogenic belts, which are collision zones, basically, collision zones between, especially continents against continents, or if you have, remember in the lecture a while ago, or in the second lecture, we discussed about two types of crust. We have um, the oceanic crust and continental crust. And as we said, itong crust, lithosphere natin is actually subdivided into jigsaw puzzle, which we referred to as the lithosphere. So para silang puzzle pieces, both of oceanic and continental nature. And when you have puzzle pieces moving around, then inevitably you get areas where these puzzle pieces collide against one another, and those are specifically orogenic belts, continent-continent collision zones, or when you have oceanic versus continental collision, you have arcs. So you have chain of volcanoes we refer to as volcanic arcs. So when you have oceanic crust involved in the collision, these are basically areas where you have the oceanic crust subducting beneath another plate. Yeah, so those are in general how mountain belts are formed, collisions. There are also chains of volcanoes, for example, submarine, gaya nitong uh, Emperor Seamount and Hawaiian Seamount chain nga. Uh, the, these are also volcanoes, but they are of a different kind. So itong chain of mountains mountains na to, submarine mountains na to, they are a special type of volcanism which we'll learn later on. So they are what we call hotspot volcanism. So they are not linked to any um, subduction zones or collision zones rather. So subduction zones are this yung ini-indicate ko kanina as trenches. So those features actually indicate subduction zone. And as you can see, nasa gitna siya ng nitong huge body of ocean. That is actually a special type of volcanic activity. So we call that hotspot volcanism. Okay, so we'll discuss more about that later. Okay, and then of course there are areas. Sabi ko kanina, if you have plates moving about, moving relative to one another, there are of course areas na nagko-collide sila. So that is where we form orogenic belts and volcanic arcs. But there are also areas where they just move away from one another. So those are what we refer to as rift zones. In the continents, we can see those rift zones here. And here, for example, sa African continent, you can see the Arabian Peninsula essentially being separated from the rest of Africa. Yan. Ito yung Red Sea ngayon. But imagine kung walang Red Sea, you can just basically put this uh, shoe-shaped continent or shoe-shaped block back together with Africa. So, yung another example of that would be this one here in the Kenya, Botswana region. So meron ka ditong napakalaking spreading or rift valley. Yan. So itong rift valley na to, if this continues to proceed, as we will see later on, it will turn into an ocean or a sea as well. Okay? In the oceans, yung rifting na yon that has progressed already, we refer to that as the oceanic ridges. Okay? So itong mid-oceanic ridges, for example, this ridge here, itong mountain belt na to, submarine mountain belt nga, imagine that this is, sabi ko last time, I think, nasabi ko na siya, this is the area where new oceanic crust is formed. You can easily imagine, paano pag walang ocean dito, then um, we can imagine itong South American plate being essentially connected to Africa without this ocean separating them. So the story of this mid-Atlantic ridge is of course para siyang itong continental rift natin that continued to progress, developing into something more like the Red Sea, and then eventually into a full-blown ocean, kumbaga. Okay? Yan. So, sabi ko rin kanina, may areas na puro volcanoes or puro mountain belts. Meron ding areas na flat lang. And those flat areas are what we refer to as tectonically passive margins. So, tectonically passive meaning wala masyadong activity in terms of plate collision or spreading. Yeah, so we refer to that as passive margins. So here in the continents, for example, we have um, we have yung South America, for example. So this is an active margin, active collision zone, and this is an area we refer to as a passive margin. Okay. Um, lang. Okay. So, yeah, so active and passive margins. We'll learn more about them later. Yeah. So cratons are the stable interior of a continent. So yung kanina, yung mga flatlands kanina, actually the reason why they are very flat, for example, yung African continent, yung Eurasian continent, yung North American continent, yung region are very flat. The reason why they're flat in the first place is that they are tectonically ano nga, inactive for millions and millions of years. Ito, thousands and millions of years. Technically, halos walang nangyaring tectonic activity sa kanila, and they are actually the core of our continent. So they are what we refer to as the craton. So the craton is a stable interior of a continent. This is usually composed of ancient, when we say ancient, billions of years old na crystalline basement rock. So this crystalline basement rock, essentially halos wala nang nangyayari sa kanyang changes. And the shields are the basement rocks that crop out extensively. So for example, yung mga areas in orange, whereas platforms are parts of the cratons na hindi exposed sa surface. At natabunan sila ng younger sediments through geologic time. Okay? So here in so you can see that all the continents have their own, sorry, all the continents have their own cratons, so even the Antarctic shield, for example, here. And then the rest of the areas in green, Phanerozoic origins na sila, meaning relatively younger itong materials na in green. Okay. Right. So sa oceans naman, yung na-mention ko nga before, we have mid-oceanic ridges, guyots, and seamounts. These represent essentially volcanoes, submarine volcanoes. The oceanic ridges are where new oceanic crust is being formed. Guyots and seamounts represent generally mga hotspot volcanoes, meaning volcanoes that pop out of nowhere. We'll learn more kung bakit nagkakaroon ng ganon. They're not linked to any spreading center or even trenches, hindi rin siya related doon. And then, yung kanina, kung mapansin ninyo, yung chain of volcanoes actually don't look very straight. Sometimes, as you can see for here, medyo sobrang, you can see this line of volcanoes that are actually transposed, or we call that faulted. So basically, this chain of volcanoes is laterally translated papunta sa right nitong chain of volcanoes na to. So because this translation of these volcanoes, or itong parang hati-hati between these spreading centers, are what we refer to as transform faults. So transform faults are faults that connect yung spreading centers natin, or yung oceanic ridges natin. So the reason why that is imagine you have a sphere. If you try to cut it straight lang, mahirap siya. If you have a basketball, for example, na very solid. So the easier way for something rigid, so rigid to be cut, is actually vertical, horizontal, vertical, horizontal, vertical, horizontal. So yung horizontal hati na yun yung ating transform faults. And then again, you have active and passive margins. Active margins are usually the areas of collision. So you get there the trenches. Again, trenches representing yung areas where you have an old oceanic crust, or oceanic crust being subducted beneath another material, either an oceanic crust or a continental. Yan. And then, yung areas naman na walang collision are what we refer to as passive margins. Sa continents, we have the continental shelf, slope, rise, and abyssal plain, followed by submarine canyon. So this is how they look like. This is basically the beach, yung continental shelf. Dito tayo nangingisda, dito yung mga coral reef, so dito yung swimming area. Lahat yan nangyayari dito sa continental shelf. As soon as the dito, the elevation drops, yun yung ating tinatawag na continental slope. So yung continental slope, basically siya yung cliff na submarine cliff, and basically that outlines yung boundary between the continent. So later on, natututunan natin na sea level actually changes. Sometimes it rises, sometimes it falls. But in general, yung sea level na yun ay always within the continental shelf only. Okay? And then, also, so continental slope and then continental rise, yung parang gentle change in elevation. And then eventually you have the abyssal plain. The abyssal plain, traditionally, yung oceans natin, we can think of it, that has been thought to be relatively flat, but we now know, of course, that that's not the case. You get again yung mga submarine volcanoes nga, we refer to as mid-oceanic ridges. Paminsan may mga hotspot volcanoes, or hindi naman necessarily hotspot, pero uh, popping out of nowhere na volcanoes. We call them which we refer to as seamounts. Yan. Kapag underwater, we call them guyots. Kapag pagka submarine volcano siya, tapos essentially flat top na siya. Okay, because of other processes like weathering and erosion. Yeah, this is an image of mid-oceanic ridge. So you can see this chain of volcanoes, and then every now and then you get this parang essentially ito yung center of volcanism, pero minsan may mga sumusundot-sundot na magma, molten rock popping out of nowhere, and that forms itong mga volcanoes na to. Okay, itong mga submarine volcanoes na to. Seamounts or guyots if it's flat top. Yan. And then trenches naman on the other hand, siya naman yung areas where you have which mark essentially your subduction zones. And this is area where you have an oceanic crust. It's always an oceanic crust subducting beneath either another oceanic crust or a continental crust. Okay? So kung saan essentially nag-disappear yung ating crust, oceanic crust, andun yung deepest regions of the crust, which are the trenches. So these are depressions where oceanic crust is consumed. And they are also the region where where we find the oldest oceanic crust. So as I mentioned before, the oldest oceanic crust that we have is way younger than continents. So pinakita ko kanina yung continents are billions of years old. Yung oceanic crust natin, hundreds of millions of years old lang siya at the oldest. Okay? Yeah. And this brings up us with the isostasy. So, with these different Earth's large-scale features, ano kaya yung itsura ng boundary between the lithosphere, which is relatively rigid, versus the asthenosphere, which is relatively plastic, as we discussed before. Ito medyo may initial clue na kayo. As you can see from here, hindi flat yung boundary between the lithosphere and the asthenosphere. Since you have a solid or a very rigid material sitting on top of something more plastic, you can imagine na para siyang ball on a pillow. The pillow will basically bend depende kung ano yung weight, distribution ng weight na nakapatong sa kanya. So that is the concept of isostasy. For the longest time, it's intrigue naturalists, scientists, kung paano yung interaction ng crust sa subsurface. And there are three basically concepts or three basic ideas on how that crust, here labeled crust, but it's actually the lithosphere. Just think of it as lithosphere. How the lithosphere and the asthenosphere interacts with one another. So the isostasy is a concept of a floating lithosphere in gravitational equilibrium with the Earth's asthenosphere, such that the tectonic plates, which are again the lithosphere, composed of lithosphere, float at an elevation which depend on their thickness and density. So again, ulitin ko, although it's labeled here as crust, this is actually lithosphere interacting with the asthenosphere. So there are three main models: Airy-Heiskanen model, or basically the roots model; Pratt-Hayford model, which is the floating model; and then Venning-Menes model, or the flexural model. So simple lang naman to. The Airy-Heiskanen model suggests na kung ano yung bundok sa taas, meron siyang reflection sa baba, which acts as its roots. So parang yung buildings natin, for you to have a tall building, you should have a very deep root, which we call a foundation. So that keeps the building in place. So you can think of it that way. So yung area has cannon model suggests that mountains have roots extending down into the mantle. Thus, the elevation of the mountain is proportional to the depth of the underlying root. So parang yung buildings nga natin, the higher the building, the higher din yung foundation or the deeper din yung foundation niya. The Pratt-Hayford model naman argues that it's not the case. Maybe there are variations in the density of the rocks comprising a mountain, so that lower density mountains, lower or sections of the mountain which are less dense, uh, float higher above the more dense materials dun sa ating lithosphere asthenosphere boundary. So the Pratt-Hayford model suggests that elevation is inversely proportional to density. Thus, the higher the mountain, the lower is its density, such that light rocks float higher. So, which is true between these two? It's actually a mixture of both. So, the Venning-Menace or flexional model is the one that we or siya yung pinaka-back ng evidence, which suggests that basically the lithosphere acts as an elastic plate, elastic plate, and in its inherent rigidity distributes yung local topographic loads over a broad region by bending. So basically, we'd like to think that the asthenosphere is actually plastic enough such that depende sa ano yung distribution of weight through time. Of course, mountains are formed and mountains are eroded. So nagbabago-bago rin yung distribution of weight, and therefore yung asthenosphere natin, which is plastic enough, it's able to distribute that weight. So for example, if you look at this, for example, yung mga sino ba? Hindi masyado kita dito. Hindi masyado kita. Sige. Dito na lang tayo sa one example that I saw to see. Yan. So for example, if you have collision zones like this, so you form mountain ranges such as this one, but as soon as eventually, hindi pala as soon as, eventually, through time, millions of years, yung mountain range na yon gets flattened through the slow process of erosion. So in the meantime, at the same time pala, at the same time na na-erode tong mountain na to, it must be transported and deposited somewhere else. So you form basins such as this, where you have deposition both here and dito sa likod. So here you have mass subtraction, and here you have mass addition. So the asthenosphere through time also adjusts with the load sa taas, so that here, as you can see, yung kumbaga root ng lithosphere natin gets less and less shallow dito sa old mountain range, whereas it gets deeper kung saan nade-deposit yung new material. And we can see that, so ito yun siya. When you have collision like this, it brings about uplift and at the same time subsidence of the continental crust. But as soon as wala na yung push na to, then this lithosphere starts to in a ductile manner spread. And at the same time, the root, kumbaga, starts to be uplifted. So, nafa-flatten out siya essentially. It's a long process. For example, we can see that here. So this is a region in Norway. I think we should play. Yeah. So the story is like this. This area originally was under or was covered by ice sheet. So malaking makapal na glacier yun nandito dati. But as soon as nawala na yung glacier, so you had mass being by natural process, yung melting, and also of course global warming or warming of the climate, all those processes eventually led to the mass or the glaciers above this region to slowly melt away. So let's see yung rebound nung lupa as soon as the mass has basically been lifted. So this is minus 5,000 years ago. As you can see, more and more continental material or more and more land is basically bouncing up essentially, so that sea level is falling in this region. So bumababa yung sea level kasi umakyat yung lupa. Ayan. So this is very definitive proof of isostasy. So, ito rin yung continental shelf natin na sinasabi ko kanina. So, yung continental shelf, siya yung relatively shallow region that changes yung area or the amount that is exposed changes with changing sea level. So, yan. So, itong mga region na to, may mga names na siya, as you can see. The reason why they have names is because they are exposed now. Pero 5,000 years ago, that region, when it was covered with ice, was actually under the sea as well. Yan. Right? Yan. And ito naman, so yan na yung ito yung part ng 2,000 years ago or 2,000 present actually. Ito yung part ng isostasy. Ito naman yung from here on out. Ito naman yung effect ng sea level rise. So, of course, habang nag-stabilize na yung plains pero with sea level rise, yan, slowly kinakain na siya ulit. Hmm. Ano, tsaka back to ano pala to. Yan. Back to animation pabalik sa time. Okay. So, that's for part 2. I'll send another pre-recorded lecture for the beginning of part 3, chapter 3, which is plate tectonics. Okay. On Tuesday, and next week I'll send another email if I'll be able to meet you face to face, or we'll have to do it in a pre-recorded lecture. And then definitely by next week, the week after that, bale Feb 27 pala, I'll be able to meet you face to face na. Okay? So, tingnan natin. Baka doon na lang din yung quiz. Okay.